Today we're going to learn about how the sun heats the earth and what light or radiation really is. Okay? So, how does the sun heat the earth? Take a guess or use your prior knowledge to how the sun actually heats the earth. So, the way I like to think about this is like a fire, right? So if there is a fire that I'm near, right? So a big fire that I'm near, and I put my hands out, right? I can feel the heat coming off that fire, right? So I'm nice and close to it. But if there is a fire a mile away, big fire, a mile away, I can see the fire, right? But if I put my hands up, I have a hard time feeling the heat. But I may like look at my hand and notice that my hand is lit up, right? Because that fire is producing light. So a really strange thing is that the sun is 92 million miles away from the earth. So we can't necessarily feel the sun's heat in the sense that you would think of like, oh, like you go next to a radiator and we feel the sun, we feel the radiator's heat. We're actually just feeling the sun's light. So what is heating the earth? The sun's light is heating the earth. And specifically, we have this stuff called infrared radiation. So we call the sun's light sol meaning sun, insolation. And that just comes from this word incoming solar radiation. We just combined in from incoming, sol from solar, and ation from the word radiation. Remember, radiation means light. Radiation means light. So incoming solar radiation is what we call insolation. This is different from the insulation with a U. If we swap that out with a U, insulation would be like this container here. So this container is an insulator, meaning that it keeps heat in and it keeps the cold out, or the opposite. It keeps the heat out and it keeps the cold in. So in an insulator with a U, we can keep things that are hot, hot, keep things that are cold, cold. But insolation is completely different. It's just what we call sunlight, insolation. So let's get into what sunlight really is. Insolation is made up of three forms of light. So the light that we can see is the rainbow, Roy G. Biv, which we call it. So that's just all the colors you can see, from red, blue, all the way up to purple. We can see that spectrum here. But the sun also produces two forms of invisible light that reach the earth. The first form of invisible light is what we can feel. We evolved as humans to feel infrared, which is actually just heat. So you can't see heat, but you can feel heat. So when you go out and you put your hand up to the sun, you're feeling the infrared long wavelength. Remember, because red light is long wavelength, and it's going to be an even longer wavelength that we feel as infrared. Most of the sun's light is white light, which is visible light. And then a little bit of the sun's light is ultraviolet, which causes sunburn. So what we can see here is that we have all these different wavelengths from radio, microwave, infrared, visible light or white light that we see, ultraviolet, which gives us sunburn, X-ray, and then gamma ray. These are all wavelengths of light, and it just happens to be that the sun mostly produces what's in the middle here, from infrared, visible, all the way up to a little bit of ultraviolet. Okay? So I'm going to have you guys watch these videos after this, but this is the main idea behind this. So the sun is producing this spectrum of the wavelength, meaning that all these other wavelengths, these super short gamma rays, X-rays, and a lot of ultraviolet are not being produced by the sun. A little bit of ultraviolet, visible light, and a little bit of infrared are being produced by the sun. But then these really long wavelengths are not being produced by the sun, okay? So the sun is producing these three, and we see the visible light. But the main idea, again, like what I'm trying to say, is that the shortest wavelengths are going to be on the left side, and these are the highest energy. So you see how fast these wavelengths go up and down, 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 up and down. The wavelength is going to be so short that it's super high energy. It's like if I wanted to replicate it, I have to go like this, and I use a lot of energy to do that. It's a lot easier to replicate a radio wave because it's lower energy. All right? So the longer the wavelength, or increasing the wavelength, If we increase the wavelength, you could do this at home. Increasing the wavelength makes it a longer wavelength, and a long wavelength doesn't have much energy. If we are decreasing the wavelength or making these waves shorter, here's the wavelength here, very short, and we get shorter and shorter as we go over to the side. If we want to do that, it's very high energy, okay? So if you get hit by gamma rays, if you get hit by X-rays in high amounts, and if you get hit by ultraviolet rays in high amounts, these are very high energy. They will punch right through your cells. They will enter your body, right? Let's think about infrared. Infrared is heat energy. It's a longer wavelength, and we feel it on the surface of our skin, right? When we feel heat, we feel it on the surface of our skin. It can't punch through our skin and go all the way into our bodies because it's lower energy. Same thing with microwaves and radio waves. These actually just pass through us without causing any damage because they're such long wavelengths. So let's ask some questions. Which wavelength has the higher energy, ultraviolet or infrared? Ultraviolet has the higher energy because it's on a decreased wavelength. If we decrease the wavelength and make the wavelength shorter, we are going to have higher energy. Unlike infrared, which has an increased wavelength, which makes the wavelength longer, which is lower energy. All right? Which form of visible light is going to have the longest wavelength? So if we're looking at this increasing versus decreasing wavelength, if we are increasing the wavelength, we're making the wavelength longer and longer and longer. So red light is going to have the longest wavelength, okay? And then finally, what form of electromagnetic radiation has the longest wavelength? Okay? So without this being here, you're not going to have this, but you'll have this. You have to understand that when we decrease wavelength, we are making the wavelength shorter. So the longest wavelength is going to be all the way on the furthest increasing wavelength side, which is going to be radio waves. Okay? So that's the main idea here. You're going to have this. This is on page 14 of the reference table, and it's called the electromagnetic spectrum, which is also forms of radiation, which is also light. So electromagnetic radiation and light are going to be the same words, same definition.